Charles' law, the volume of a gas and its Kelvin temperature are directly proportional at constant pressure. So this equation shows that the volume is directly proportional with the temperature. Now, if two variables are directly proportional, then increasing one by some factor increases the other by the same factor. So when the temperature of a gas sample in kelvins is doubled, its volume doubles. So that is the meaning of direct proportionality. So the formula for Charles' law is this: V1 over T1 equals V2 over T2, where V1 is the initial volume, V2 is the final volume. T1 is the initial temperature in Kelvin, and T2 is the final temperature in Kelvin. And to convert degrees Celsius to Kelvin, then this is the formula. Degrees Celsius plus 273. So here is a problem. A gas in a cylinder with a movable piston has an initial volume of 90 ml and is heated from 50 degrees Celsius to 100 degrees Celsius. What is the final volume of the gas in milliliters? So the unknown is V2. So the given are T1, which is 50 degrees Celsius, but it should be expressed in Kelvin, so plus 273 equals 323 Kelvin. T2 is 100 degrees Celsius, but again, it should be in Kelvin, so adding 273 gives you 373 Kelvin. And then V1 is the 90 ml. And the unknown is V2. So if you analyze the initial temperature, which is 50 degrees Celsius, is lower than 100 degrees Celsius, which is equal to 373 Kelvin. So it is almost a difference of 100 Kelvin, right? So we will expect that because according to Charles' law, as temperature increases, the volume increases. Therefore, we should expect that the B2 is larger than 90 ml. So let us proceed. So B1 over T1 equals V2 over T2. Transpose B2 to the left. So we have T2 over T1 times B1. So substitute the value of T2, 373 Kelvin divided by 323 Kelvin. You need to cancel Kelvin, Kelvin. Then the factor is 1.15 and multiply it by B1, which is 90 ml. The answer is 104 ml. Does it make sense? Yes, the V2 is larger than B1. The next problem, a gas with an initial volume of 80 ml and temperature of 60 degrees Celsius is heated until the volume reaches 160 ml. What is the final temperature of the gas? So T1 is 60 degrees Celsius. Adding 273 so that it becomes Kelvin is 333 Kelvin. The unknown is T2. V1 is 80 ml and V2 is 160 ml. As you notice, the volume is doubled. Therefore, according to Charles' law, the volume of a gas is directly proportional to the temperature. So if the volume is doubled, most likely the temperature must be doubled. So this is again the equation. Now transposing T2, then substitute V2 over V1, cancel milliliter, milliliter, 160 divided by 80 is 2. So 2 is the factor times T1, which is 333 Kelvin. The answer is 666 Kelvin. It makes sense. From 333 to 666. So the volume is doubled. The temperature in Kelvin is also doubled. Now, if you will be asked in the problem, what is the temperature in degrees Celsius? Then this is the formula. Degrees Celsius is Kelvin minus 273 and it is equal to 393 Kelvin. So these are the equation for Charles' law. This is the general. Now, if the unknown is B2, if the unknown is T1, and if the unknown is B1. These two are temperature conversion from Kelvin to degrees Celsius and degrees Celsius to Kelvin. So another law is Gay-Lussac's law. According to Gay-Lussac's law, the pressure and the Kelvin temperature are directly proportional at constant volume. So this equation is showing the proportionality, the direct proportionality of pressure with temperature. So again, if two variables are directly proportional, then increasing one by some factor increases the other by the same factor. So the relationship between the temperature and pressure of a gas follows from kinetic molecular theory, that if the temperature of a gas is increased, the kinetic energy of the gas particles is increased, causing the gas particles to move faster, thus the pressure is increased. So we say, as the temperature increases, the pressure likewise increases. So the general equation for Gay-Lussac's law is this: P1 over T1 equals P2 over T2, where P1 is the initial pressure, P2 is the final pressure, T1 is the initial temperature, again in Kelvin, T2 is the final temperature in Kelvin. So to convert again, degrees Celsius to Kelvin is simply add 273 to Celsius. Here is a problem about Gay-Lussac's law. A sample of gas has a pressure of 103 kPa. So this is the initial pressure, P1. At 25 degrees Celsius, so this must be T1. What will be the pressure of the gas? So this must be P2. When heated at 928 degrees Celsius, the volume remains constant. So 928 is T2. So what are the given? P 103 kPa and P2 is unknown. T1 is 25 degrees Celsius. Convert it to Kelvin plus 273, 298. T2 is 928. Convert to Kelvin plus 273 equals 1,201 Kelvin. So as you can see, from 298 to 1,201 shows 4 times increase, quadrupled. The temperature is quadrupled. So this is the general equation for Gay-Lussac's law. Because the unknown is P2, then transpose P2 to the left and substitute T2 and T1. Make sure to cancel Kelvin and Kelvin unit. So the factor is 4.03 times 103 kPa, which is the P1, gives you P2 415 kPa. So observe, 103 kPa initial, the temperature was quadrupled, increased quadrupled. Look at the pressure. It makes sense, right? Okay, here are the equation using Gay-Lussac's law. When the pressure is showing direct relationship with the temperature and the volume is constant. Now, if the unknown is P2, this is the equation. If the unknown is T1, if the unknown is P1, against these two are the formula for conversion of temperature.